So we're saying they show some association because they benefit from each other, say for survival. And then some would show some associations because of the soil type, which enables them to grow in particular environment closely associated to each other. And then some species form association because of the nutrients, which is found in certain environments. Therefore, not all species which form associations do get benefits from each other. Some they just form associations just because of the soil types, because of the same kind of preferences of nutrients, maybe some because of the slope, the south and north facing slopes, preferring more sunlight or more shade, but they normally would not benefit from each other. And then some species, they do not form associations at all. For example, a species such as the Androstachys johnsoni, it is said that it cannot form any association with other species because of the allelochemicals which inhibit the growth of the other species. So if you find Androstachys johnsoni growing, you would not see any other species growing in its vicinity. So it hinders the growth of other species and also of its seedlings. You cannot find its seedlings growing around it because of the chemicals that it releases. So the invasive species cannot form an association because once they get an opportunity to germinate, they monopolize a certain area and then outcompete the natural species or native species which were occurring in that particular area before them. And then the social table analysis, the step 3 and 4, is the differential table. So the goal is just to identify the groups of species that characterizes the various associations. So these are the species with the intermediate consistency, that is around 10 to 60% consistency. So the species with the high consistency are characteristics of the entire group of relevates, and they are said to be not useful. So the species with the low consistency are likely not to be the characteristics of the relevate. Then here we have now the sorted differentiated table. So this table was constructed from the previous raw data table. So here now you find that the species which show some association are grouped together into groups. As you can see there, we have group A, group B, group C. So these are the species which were seen to be occurring, showing some consistency in different plots. So they were grouped together. And you will find that some of the relevant numbers have been omitted, some due to the fact that the sites which they were occurring are said to have been disturbed. So if a site is disturbed, which means it does not show any species. Then after all that, when you have passed all those steps, you come to the last phase, which is the syntaxonomic phase. So here now is just to determine the formal names of the vegetation units according to the international rules of nomenclature. So you show relationships to existing units within the hierarchy of the nomenclature. So this should have been very simple to understand. So the association analysis is just a method which is used to classify different types of species which are seen to be forming an association or which occur in pairs in ecology. So this method concentrates on classifying pairs of species. So it is one of the most widely used classification methods of plant ecology for the last decades. So the objective now here is to simplify the data and present them graphically rather than in tabular forms like in our other analysis. So this method cannot be applied in the relevant data because it focuses only on pairs of species, and the relevant method, as we know, it looks into community of species. So in order to classify species according to this method, you must first construct some quadrants in a particular environment. Then observe how the species occur in each quadrant. Then identify the species which occur most in different quadrants, but seeming to be forming pairs, occurring in pairs with other species, and record this species as the first differential species, and again identify the second differential species. After identifying the species, you must then calculate the chi-square value in order to represent those species in a dendrogram to show how they form an association. So how does an association occur? So species can form association because they benefit from each other for survival. They can show some association because of the soil type. If they prefer the same kind of soil, then they would occur at the same place. And also, if some species form association because of the nutrients in the particular environment, but then not all species are seen to be forming an association. And also, if they do form some association, it does not mean that they always benefit from each other. So then, coming to the first phase, which is the field phase, which involves the relevant method, or what we call the Brown-Braithwaite method. So then the choice of the sample site should avoid mixed, or what we call the heterogeneous stands. As you know, for a site to qualify for a relevant, it needs to show some homogeneity instead of heterogeneity. So we have to find also a minimal area. As you know, that's one of the aims of the relevant methods. And then it should be show some centralized replicate sampling. So the Brown-Braithwaite cover abundance estimates, and then also the collection of the site and soil data is part of the process in this particular case when you are trying to classify vegetation looking at the entire flora. Then the second phase, which is the analytical phase, which involves also the sorted tables. So the goal of this phase is to prepare a table that show the relevant data in the organized form. So the raw table is constructed, and then the species are recorded according to occurrence of each species forming a consistency table. So species of the intermediate consistency are used to form a partial differential table. So this table is reordered in relation to the presence or absence of differentiating species into differential tables. So we find that the analysis, the association analysis, it builds the dendrogram from top to bottom rather than from bottom to up as in clustering. Therefore, the dendrogram of association analysis differs with that of the cluster analysis. So the first step now with the association analysis is to compute the chi-square value for every pair of species. So the species having the highest sum of the chi-square values with all the other species is selected as the first differential species. So in this case, we have got 70 as the number of species. And then we go there at 48 at the chi-square value. The highest chi-square value was obtained from the species number 32. So which means that we are going to avoid going to the right, then we're going to move to the left, because at the right we will find other species which do not form an association with this particular species. So we move this side, and then the chi-square value of 48. Then from there we are going to look for the second differential species on the right, not on the left. Therefore, we find it at the chi-square value of 10 and its species number 38, which means it is forming some association with species number 32. Therefore, still again, we are not going to go to the right, we are going to go to the left, because to the right we won't find species which is forming an association with species number 38. Therefore, we're going to go down and look again for another species which is forming an association with this one. So this is how an association analysis a dendrogram builds up. So it builds up from the top to the bottom instead from the bottom going upwards. Good morning, ladies and gentlemen. So we are going to move on to another chapter this morning. So we're going to be looking at the classification and ordination of plant communities. So classification in simpler terms, we're just going to be looking at the classification methods which are said to attempt to place similar stands together in distinct entities. So that is in associations or other units which are cleanly separated from other stands and units. And then in this chapter we are going to look at two different types of classification, mainly classification based on dominancy and also classification based on the entire flora. So with the classification based on the dominancy, we want to talk more about the claimants. Then so the claimants are said to have classified the North American vegetation on the basis of only one or two dominant species in each unit. So sometimes the dominant taxon was listed only to the genus level, which implies that the species might vary locally within the vegetation unit. This is an extreme emphasis on the overstory dominance and the results may mask the important variations which occur in the understory vegetations. And then we come to another subheading, which is the cluster analysis. So the cluster analysis is just the task to group a set of plants in such a way that plants in the same group are more similar to each other than those in the other groups. So its objective is just to simplify data and to represent data in graphical forms rather than in tabular forms. So the resulting figure is seen as a dendrogram of stands, similar to the dendrogram of species that a numerical taxonomist would construct. So the first step is to express the similarity between two stands in a single number, which is called a community coefficient. So there are many ways to calculate the community coefficient. All the formulas indicate the relative number of species shared by two stands or quadrants. So a CC of 100 represents identity, whilst a community coefficient of 0 represents complete difference. So the rule of the thumb here is that any two plots with a community coefficient of more than 50%, they are said to be of the same association. So after the CC values are computed for every pair of stands, the two stands with the highest CC values are plotted on the graph as vertical lines, which are joined by the horizontal lines at that CC value. So the cluster analysis dendrogram can be used for the classification of the investigator if the investigator selects some threshold value at which to define the association. So as already mentioned, stands of one association are often expected to share a community coefficient above 50. So this is how a row table would look like. So with the rows representing what we call the relevant number, and then the columns representing the plant species. So it should be clearly visible on the notes that you have with you there. So in this particular case, we're trying to group species which seem to be occurring in association, in close association. We group them together so that later on we can try and classify our vegetations according to the occurrence and also maybe the absence of some of the species. If some species keep showing up in different areas, but then they keep showing appearing constantly, so the frequency of their appearances together becomes more and more as we checking or replicating our quadrants, and then we're going to put those species together. So this is just a row table which is still to be sorted again. So the cross there, they're indicating the cover which is less than 1%, which means then that sociability there, or what we call association, is understood to be 1 unless if it is noted. In this particular phase, we're trying to organize the species which show some association. We put them together in a table. We're trying to sort them into groups. So then it involves some steps. So the first step is the row table. So you find that we have the columns, which would be representing the relevant numbers, and then we'll be having the rows representing the species, as you will see in the figure which will follow. So the order of arranging the data is not important, but it is advised to arrange the species along the gradient from dry to wet or from wet to dry. So the code in the table which will follow will refer to cover abundance and also sociability. And sociability is just an expression of the horizontal pattern of the species and the degree of clustering of species. Then we have the classification based on the entire flora. So we're saying that the plant community types are conceived as units based purely on their total floristics approach. So among species that make up a community, you find that there are species which are better indicators of a certain vegetation. So these species, we often term them the diagnostic species. So the diagnostic species are used to organize communities hierarchically. So we have got three phases in this particular classification of Brown-Brackett approach. So the Brown-Brackett, as we know, is the relevant method. So the first phase is the field phase, which focuses on the collection of data, the relevant data. And then the second phase is the analytical phase, which involves the sorted table analysis, which leads to differential tables. And then we have the syntaxonomic phase, which is the last one, which involves the naming of the unit according to the international rules of nomenclature, and also the placement within the hierarchic system of syntax. So the International Code of Botanical Nomenclature. The second step is the consistency table. So here we're trying to arrange the species according to consistency of occurrence. If two species seem to be occurring in different places together constantly, which means showing some consistency. So this is how many plots a species occur in. So if species 1 and 2 are occurring in, say, in plot 1, plot 2, plot 5, plot 6, plot 7, and then we are going to put those particular species together or group them together. So then the calculation of the relevant frequency for each species is the number of occurrence over the number of relevant multiplied by 100. So this will be a percentage. So then the table is rearranged to highest consistency to lowest consistency. So that is from the highest consistency to the lowest consistency. So therefore, in some regions, the overstory dominant may remain constant, while the ecological important understory changes occur. So then, in light of this, the Dobomir in the 1952 they modified this Clement simple scheme by listing 2 species per unit. So that is an overstory species and also an understory species separated by a slash. So in this way, for example, a Pinus ponderosa slash Bushia tritonate tree shrub mosaic could be classified from a Pinus ponderosa slash Agropyron spicatum woodland grass mosaic, whereas in the latter, in the earlier classification, it would only be a Pinus ponderosa unit only, without the 2 other understory species which may differ. So in simpler scheme, they would be harmed together as the Pinus ponderosa unit, like I just mentioned. So in order to classify vegetation on the basis of dominancy, any quadrant transect, point, or distance sampling method can be used if it yields data that can be relativized. So dominancy can be based on relative canopy cover, density, basal area, biomass, or sum of any of these. That is when we start talking about the importance values. So basically what we're trying to say here is that with the Clements, they only looked at the overstory species. So when we're talking about the overstory species, we mean the large tree species. So the large trees, and not focusing on the smaller trees such as the herbs and also the grasses. So the Clements only looked at the large trees, and then they classified their vegetations according to that. For example, let's say you have a community wherein you have marula trees dominating the particular area. So you were going to classify that particular area as a marula woodland, and then not focus or look into the other smaller species which are found underneath the marula vegetation. But then with the Daubamie, they came and tried to classify their vegetations by looking at 2 species, the overstory species and also the understory species. So if you have a marula vegetation dominating an area which is an overstory species, and then we also going to look what is found underneath that particular vegetation which is dominated by a marula species, which means we're going to look for herbs and shrubs. If we find that there are other smaller shrubs which are dominating, for example, let's say you find that there is a Bidens spilosa, which means you're going to say this area is mainly dominated by, you're going to classify it as a marula slash Bidens spilosa woodland unit instead of marula unit.